Good morning. I'd like to welcome and thank Professor Barnett for his visit and for coming here to give us a lecture. I'd like also to thank MIT's Law School of Management for the financial support, and also Amigos da Poli, our endowment, especially Gustavo Pierini, who had the good idea to bring Professor Barnett for giving us a lecture on mass modeling with a focus on problems of health and safety. I'd like to present Professor Barnett's professional career, a resume. Professor Barnett, the George Eastman Professor of Management Science and the Professor of Statistics at the MIT Sloan School of Management. Professor Barnett holds a BA in Mathematics from Columbia College and a PhD in Mathematics from MIT. Professor Barnett has written op-ed pieces for the New York Times, the Wall Street Journal, the Boston Globe, CNN Opinion, the Charlotte Observer, and USA Today. He received the President's Award and the Expository Written Award from Informs in 1996 and in 2001, and is a fellow of Informs, cited as the nation's leading expert on aviation safety. Professor Barnett was recognized with the 2002 President's citation from the Flight Safety Foundations for truly outstanding contributions on behalf of safety. MIT Sloan students have honored him on 14 occasions for outstanding teaching. Congratulations, Professor. Let's welcome Professor Barnett.
Thank you so much. Obrigado. I'm sorry, ladies and gentlemen, that I can only give the presentation in English. You know, it's said, if you know 2 languages, you are bilingual. If you know 3 languages, you are trilingual. If you know 1 language, you're from the United States. So I'm afraid I only know the 1 language and have the greatest admiration for you because you can study in English but also in Portuguese and Spanish, and I could not do that. So I'm very honored to be here. What I'm going to talk now is about death. In particular, the title of the talk, and I'm happy, of course, to provide the slides to anyone who wants them. Electronically, I can send you the PowerPoints. All the same, uncertain patterns in cross-national death risk. And let me tell you how I got interested in this topic. You may have heard of Charles Spearman. You know, Spearman of the rank correlation test, a very great contributor to statistics. But he also did a good deal of work on the notion of intelligence quotient, or IQ. And what he found was that the people who were successful, for example, on mathematics tests were the same as the people who were successful on tests of reading or geometric space perceptions. That basically, if you did well on one dimension of intelligence, he argued, you tended to do well on all of them. And he therefore said there's some underlying factor, which he's calling IQ, which generates your success scores on all of these different dimensions. I might add that the notion of IQ is somewhat controversial, particularly today, but it got me thinking, is it possible that the same thing happens with respect to mortality risk? Meaning, as people were kind enough to say, I have studied aviation safety, and I thought, well, are the countries that are less safe in aviation or transportation in general the same ones that have more industrial accidents, the same ones that have higher infant mortality, etc., the same ones that tend to have more deaths associated with lifestyle, eating the wrong foods and smoking cigarettes, that if we think of all the sources of death, is it the case that countries that tend to be relatively safe on one of them tend to be relatively safe on all of them? And that is one of the questions I will be discussing today. But then there's also another question. It never hurts to use common sense. Even if one country is a lot safer than, it's safer than another one on all 6 dimensions that I'll consider, if the difference in longevity and lifespan is only 3 months, then the differences don't matter so much. So how big are the differences across nations in terms of premature deaths for the various reasons? And we'll talk about that. Another question is, well, we will find, as you'll see, some countries are statistically safer than others. Is that correlated with wealth? Are wealthy countries better able to have excellent medical care, better able to have the safest roads, et cetera, et cetera? So those are the questions I'll consider today in a brief empirical study. I will consider 6 sources of premature death. Now, my understanding is that all of us die sometime. I myself am hoping to avoid that, but I don't expect to. But in any case, ladies and gentlemen, so it's not a matter of whether we die, but a premature death means a death that's earlier than you would have had otherwise because of some problem. So here are some of the things that I'll look at today. They're all 6, and every death will fall into one of these 6 categories. Early childhood mortality, and these are from diseases. If a 3-year-old is killed in an auto accident, that's considered a transport death, not early childhood. But this is early childhood. This is considered a good proxy for the caliber of medical care in a country, because at later ages, people may die because they smoke cigarettes or the air pollution or something else, bad dietary patterns, but you're not going to see that in the first 5 years of life. That to a large extent, the differences in child mortality are considered proxies for the caliber of medical care. Transportation accidents. Did you know, ladies and gentlemen, that transportation accidents take more lives than all other kinds of accidents combined? If you think about it, it makes sense because, you know, yes, there are sometimes tragedies, industrial accidents at factories and whatnot, but those are rare. And deaths on the roads, we know, happen all the time. Now, from my limited stay in Sao Paulo, in some respect, you're very safe because the traffic moves so slowly. But in any case, transport accidents. Another category is other kinds of accidents, and those would be industrial accidents. They would also be sometimes accidents where you something hits you from the top of a building or a building fire, etc. The different kinds of accidents. Homicide is a cause of death, a deliberate taking of deaths from others. In the calculations, we don't include deaths that are part of warfare. In other words, this is sort of peacetime mortality. So tragically, a country like Syria could not be part of an analysis like this. Another category, communicable diseases, and that would include typhoid, for example, is one. AIDS is one. Influenza, which is misspelled here, but influenza is another source of quite a few deaths. So these are communicable. They can be transmitted from one person to another. And then there are the non-communicable diseases, and this is really most of them. This would be heart disease. This would be cancer. This would be diabetes. This would be suicide. These are things where the fact that I have the malady doesn't mean I can transmit it to you. If I can transmit it, it's communicable disease. So these are the 6 sources of premature death I will consider, okay? And I want to remind you that non-communicable diseases is a big category, and it involves, first of all, most of the effects of environmental pollution, water and air, are non-communicable. Some of them are communicable, typhoid fever, but most of them are not. Another category, dietary patterns. You know that if you eat the so-called Mediterranean diet, supposedly you live longer, etc., whereas other diets are less healthy. Okay, but so that's something that might be related to the deaths for non-communicable diseases. Another category is lifestyle choices, such as whether people smoke cigarettes or get physical exercise. I don't get much physical exercise, and it's always painful to read these studies which talk about all the benefits of physical exercise. You know, there was a president of the University of Chicago who said, whenever I get the urge to exercise, I lie down until I'm over it. And that would be very comforting, except that he died quite young. But anyway, lifestyle choices, and also level of stress. Now, ladies and gentlemen, I don't know, I don't know as much about Brazil as I wish I did. I'm learning as I'm here. But in some countries, such as my own, the United States, there's a good deal of stress in the way people live. And this can itself affect longevity. When there's a lot of stress, there may be more alcoholism. There may be greater heart attacks because of high blood pressure and whatnot. There may be more suicide. So these are things that actually I put in the category non-communicable diseases. Now, the fortunate thing, I mentioned here, of course, the caliber of medical care also affects how well you do in terms of these. This is the risk of getting the disease, but better medical care may mean the cancer is cured rather than the source of mortality. So medical care affects everything. It most directly affects the under 5 mortality. And now, let me tell you a little more about the data sources. For today's talk, ladies and gentlemen, I'm going to consider the 26 nations in the world that each have at least 50 million people. And you know, that it turns out that these countries are spread quite uniformly around the globe. In the Americas, we have Brazil, of course, we have Mexico, and we have the United States. In Europe, we have the UK, we have Germany, Italy, and France. In Asia, well, of course, we have India and China, but we also have the Philippines, we have Vietnam, we have Indonesia, we have Thailand, and Africa, quite a few countries there. We have Nigeria, we have Ethiopia, Egypt in northern Africa, we have South Africa, and we have, let's say, Tanzania, which on the east coast of Africa. So these countries collectively have about 3/4 of the people in the world. In my final study, I will include some of the other nations because you might think that you don't want to leave out these countries, the smaller countries. And I'll tell you, in my preliminary work, the results don't change when you add these countries. But today I'm only talking specifically about the largest one. Can you hear me, by the way? Thank you. Luckily, there's a wonderful source of data, the so-called Global Burden of Disease Study. And this study, people, presents age-specific mortality statistics for many kinds of death, for all 6 of the kinds we will be studying. So I can look, for example, in France, and I can find out something about the death rate caused by let's say, transport accidents in the age range 45 through 49. Okay, so we have these statistics for every one of the 26 countries. We have these statistics. They're considered pretty reliable. They're not always perfect, but still they represent a very sustained effort. And it's a wonderful data source. And, you know, I'm older than most people in this room, and I remember before we had, you know, laptops, etc. And to gather the kind of data that I'm able to get while sitting up in my bed on the internet, you know, years ago it would have been out of the question to get all this information, to have it collected and have it available in one source. So in some respects I'm lucky because I remember what things were like before the things which we now take for granted, like the internet, which is absolutely wonderful for this respect. Anyway, as I said, the Global Burden of Disease study allows us to estimate the average extent to which each of these sources of risk can reduce lifespan for citizens in a given country. Now, let me tell you how they do the study. It's a little odd. They start out saying that if everything goes well for you and you don't suffer premature death, you will live, on average, you'll basically live 87 and a half years. I'm not sure how they got that number. And then they got a little bit of a problem because they're saying that if you die at age 20, for example, you would have lived 67 and a half more years to 87 and a half. But what if you're already 85? They don't really believe that if you're at 85, you only have at most 2.5 years to go. So they have a little bit of a change. If you make it to 85, they give you another 7 years. So instead of 87 and a half, they basically think you'll make it to the early 90s. But basically, this is a natural death. You know, apparently there is such a thing as death of old age. And I'm sorry to be so glum, but death of old age means, you know, every part of your body is collapsing and basically the machinery is wearing out. That's distinct from the causes of death we're describing here. Anyway, so let me tell you a little bit how the study works, and let me confess something. You know, when I was preparing the talk, I didn't know that the audience would be here at the Polytechnic, where people know mathematics so well. So I thought I shouldn't use equations. If I use a sigma, then that itself will be a source of premature death in the audience. So I'm using words in places where I think a simple equation that you would understand very well will do the job, but just be patient with me for my mistake. Again, what we really can find from the Global Burden of Disease study is in any given range, age range, there are intervals of 5 years, 5 to 9, 10 to 14, etc. It will tell you the per capita death risk for people in a given country for a given cause. So it could be that in country X, if you reach age 50, then there's a 2% chance you'll die of non-communicable diseases by age 55. Those are the kinds of numbers you can get from this study. And now that shows you the probability of dying in each range, but how much do you lose? Well, again, they base it on the 87 and a half. So if you die of a disease between 50 and 55, well, you might say on average you'll die by the middle of the range, 52 and a half, so you lose 35 years of life, 87.5 minus 52.5. But they do even better than that, because of those who die between 50 and 55, it may be more of them are at 54 than at 51. In other words, it might not be uniform within the 5-year range. They will give us the actual statistic. So it may be that in a given country, the average age of death of those between 50 and 55 is not 52 and a half, but maybe 53.2 or something. So it's really a nice calculation. But how do we work it out? How do we work out the overall effect on death? And here we basically do what you would call an expected value calculation. Have you had probability? How many of you have studied probability? Oh, my goodness. This is heaven. Okay? But, I'll explain if some of you have not. But basically, the way we work out the consequences of transport accidents on your lifespan is we say, one possibility is you'll be in a transport accident that's fatal in your first 5 years of life. We work out the probability times the loss of life in that case, which is something like 85 years, right? Because you're 2.5 versus 87.5. Then we add to that the risk that you might make it to age 5 but die in a transport accident between 5 and 9. So we take the probability of that times the loss of life there, which is a little less than if you were very young, but still is big. And we add up over all the different age ranges how much you would lose if you died of this problem in that age range, and what is the probability of dying in that age range of that problem. And when we add that up, that's the overall average reduction in your lifespan. Again, I could write out the usual actuarial equation that summarizes what I just said, but here we have all of this verbiage, which reminds us how nice it is to use equations when we can. There's one thing that I really like about the global burden of disease study, and that is it avoids the problem of camouflage. You know what camouflage is? Where something hides something else? Look, if you die in a transport accident at age 35, you cannot die of an industrial accident at age 55, right? So if I'm really to talk about the effect of, let's say, industrial accidents on longevity, if I don't weed out the fact that you don't have some of these accidents because you didn't live long enough to have them, I might get the impression that industrial accidents are rarer than they actually are. But with the global burden of disease study, we can avoid camouflage. What I did was, for each source of death, I said, let's assume that is the only reason people could die. So for transport accidents, it could be in the first age group or the second, third, fourth. So we don't have that kind of camouflage where you don't have diseases. Because you don't reach age 60, you don't have diseases at age 60. Here, the only reason you wouldn't reach age 60 for transport accidents is that you died of a transport accident before 60. So it works out nicely that we can have a fair comparison across nations, because we're not basically saying that those that have lots of early deaths are less prone to deaths later on. They aren't necessarily less prone to deaths. There are less people at risk. So you're able to avoid some of the technical issues that could lead to misleading conclusions. Anyway, why don't I present some numbers now? And I'll tell you, the world championship in global risk, in terms of minimizing it, is Japan. Okay, and you from Japan? Okay, but Japan does and here are the best ratings, and we'll talk a little more, and of course I'll present you numbers for Brazil shortly. First of all, transport accidents in Japan reduce lifespan 0.17 years, which is about 2 months, meaning that if transport accidents were the only source of death in Japan prior to natural death at 87, you'd lose only about 2 months of life. Okay? Other accidents, well, in Japan, actually, the other accidents are more numerous, 0.42, so you lose about 5 months. Homicide is extraordinarily rare in Japan. You lose 1/50th of a year. That's basically, you lose 1 week on average from your 87 years because of the risk of homicide. The early childhood mortality caused by disease, again, about 2 months. Communicable diseases, there it's about a year. And the non-communicable ones, that's the big one. It's 9.54 years. When you think about it, when people do die for other than old age, most of the time it is, heart attacks and cancer and things. So it's really not a surprise that the non-communicable diseases really contribute the most to premature deaths. In Japan, adding up across the 6 categories, we get 10.82 years. That out of the 87.5, and don't forget, a lot of Japanese benefit from that provision where they let you go into your 90s, you lose about 10.8 years. But again, they really lose less than that because of camouflage. Namely, you don't get the full negative effect of these things because of deaths for other causes. Now, let's go and do a little bit more. And the first thing I'd like to talk about is not the same chart we just showed for Japan, although I will show it shortly for Brazil. But remember I said, is there correlation? I'm talking for Japan. I said, these are the 6 numbers. But is it the case that as we look across these nations, the ones that tend to do well with relatively low risk on one of the 6 variables tend also to have relatively low risk on the others? So that was the first thing I wanted to look at. And for that purpose, one should always do a simple analysis if it will suffice, rather than something so complicated people can't figure out what you're doing, okay? And I thought, why don't we just check the correlation coefficients among these variables? Is it the case that countries that are high on one dimension of mortality risk are also high on others? So there'll be positive correlation and lows aligned with low. So what I did was basically work out the correlation coefficients across the 26 nations of the different variables. And guess what? I have here, now you can't really see it, so I can pretend it says whatever I want. But in any case, that's the correlation matrix, ladies and gentlemen, which reveals the correlation coefficients for the different sources of premature death. So you'll notice, first of all, on the diagonal, you see 1s. You say, oh, isn't that amazing? No, it is not amazing. Everything is perfectly correlated with itself. But the numbers above the diagonal tell us the correlations across different variables. So, for example, for transport accidents and other accidents, the correlation coefficient is plus 0.33, which means there's a tendency to move the same way, although obviously not lockstep, where it will be somewhat closer to 1. By the way, there's no need for me to put in the entries below the diagonal because they're the mirror image of the ones on top, right? So the correlation coefficient of transport and other is the same as the correlation coefficient of other and transport. So I really don't have any new information. Ladies and gentlemen, you can't help but notice that every single one of those correlation coefficients is positive. And that's what I would expect if there really were a tendency that if you do well on one, you'll do well on the others. Now, the average of these correlation coefficients is 0.44, which, by the way, is not, those of you who've studied correlation know, this isn't that great. It's not like 0.99. It means there's a tendency to move the same way, but there are exceptions to that tendency. But on the other hand, there was a study recently of IQ, the various test results that supposedly reflect the underlying factor IQ. And it turns out, ladies and gentlemen, that if you work out the average correlation there, it isn't as high as 0.44. So if people thought there was enough basis for a latent variable, as it's called, IQ, I think there's enough for a latent variable we might call safety that pretty much generates how a country will fare on the 6 dimensions, although not by any means perfectly. Okay? Yeah, as I said, this just says what I just said, that basically that we would expect that if you do well on one of these dimensions, you'll do well on most, if not all of them. But that's correlation. And ladies and gentlemen, the correlation coefficient reflects directions, right? If you're high on one, are you high on the other? But how big is the relationship? You know, you can have a perfect linear relationship where y is x over 10 trillion. And that would give you a correlation coefficient of 1, even though, of course, y doesn't really change. So correlation coefficient says high, high, low, low. It doesn't tell you how big are the effects that we're measuring. So a natural thing to do is simply to look at the actual numbers and say, is there a big difference? And the answer is very simply, there is a big difference. In Japan, remember we got the statistic 10.82 years. At the other extreme, in Tanzania, it was 35.85 years, more than an extra quarter century. So we're not talking about second-order effects. We're talking about big effects in terms of longevity. And you might say, what about Brazil? Be patient. Brazil is coming. Okay? Not on the next slide, I don't think. Oh, here I was trying to use the, what do they call that command whereby wait, what is it? The apparition or something, when you want the different parts of the slide to come on at different times. I'm sorry, animation, yes, thank you. As you see, I'm not terribly good at it. So far, this is what I've achieved in animation. And say, then the question is, how might we summarize how well a given nation did in longevity? You know, we could use the so-called factor analysis technique that Charles Spearman used, but, you know, it's really an artificial mathematical model. You take a linear combination, a weighted average of the 6 scores, the one that in some sense best fits the data. But, of course, you can get coefficients that don't really have a natural interpretation. So I thought, why don't we just do something that's relatively simple, but I think illuminating. The first thing I would do is say, well, why not go with 2 obvious metrics? Come on. One of them is just take the sum of the 6 numbers, right? How many years did you lose? That's some measure of how well you've done. But another measure I would consider is sort of a normalized loss of life for each variable. And this basically gives each of the 6 sources of mortality risk about equal weight. You see, if we just take the simple sum, then as we saw for Japan, the communicable diseases is going to be dominant in that sum. So the other variables won't have as much of a chance to express themselves. But what we might do is normalize, and some of you may have seen this in your statistics classes. We take the nation's value, subtract off the 26 nation mean, divide through by the overall standard deviation. In other words, find out how many standard deviations that nation is away from the overall group average, okay? You've heard of this. This is what normalization is. But because of doing it that way, for all 6, we're giving them about equal weight because the numbers will tend to bob between sort of -1 and 1 or something on each of the 6 dimensions. So we have 2 ways of looking at it, the raw sum and another sort of a normalized sum that gives all 6 variables about the same weight. If there really are strong correlations among the variables, ladies and gentlemen, I would expect we're going to get pretty similar results both ways. Because if they're really all moving the same way, then whether you average them one way or another in terms of the overall final results, in terms of which nations do better than others, I would expect a very similar pattern. So let's see what happened. First of all, you see again, I didn't do so well here. This will take a few minutes. Here, come on, get out. 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 Out, sorry. Okay, we've already said two ways to measure the overall safety. We've already talked about that. All right, here are the results for Brazil, ladies and gentlemen, first of all. And Brazil is a highly unusual country in one respect. Of the 6 variables, Brazil was better than average on 3 and weaker than average on the other 3. Very few countries are like that. There are many more that it went all 6 were the same way, or a 5-1 split. Very, very few. But in Brazil, first of all, the normalized statistics on the right or tell us something, a comparison. If we look at the numbers first on the left, and again, I know it's hard for you to see them, and that's why I'm perfectly happy to give you the transparencies. You see numbers like transport is 0.89 years. Remember, it was only 0.17 for Japan. For other accidents, 0.9. Homicide, ladies and gentlemen, is Brazil's Achilles heel. Of the 26 countries, people, Brazil had the highest homicide rate except for South Africa. It was second out of 26, and it was 2.4 standard deviations above the group mean. That is the dimension on which Brazil tragically doesn't do so well. As far as under 5, communicable and non-communicable, we see these numbers. If you see negative signs, and again, you can't really see them from way back there, a negative sign before the normalized result is a good thing. That means you were below average. You lost fewer years. So on 3 of the 6, including communicable and non-communicable diseases and other accidents, Brazil actually did better than the 26-nation average. On the other 3, and in particular in homicide, Brazil did not do as well. Okay, and then I thought, well, how will I summarize the results? Because, you have these results of this type. Remember, the 2 scores. One of them is basically the total loss of longevity, and the other is the normalized loss. And I thought maybe to make it easier for people to make comparisons, I'd put these numbers on a scale 0 to 100, which is sort of a common scale. It could have been -1 to 1 or something, but I thought 0 to 100 so we wouldn't have to wonder what a negative means, what a positive means. And let me just show you what the results look like. And here are some of them. Obviously, there are 26 at the moment. The country that did the best was Japan. It got the highest score, 100, on both ways of measuring risk. The simple sum of 10.82 or the weighted sum, the normalized sum, which doesn't give greater weight to the variables like non-communicable diseases. Japan was up on top both times. The U.S., we were at 81-81. In other words, closer to the top than the bottom, which was good. It was not obviously at the best, but it's still. For France did very, very well. It had 94 on one dimension and 92 on the other, meaning, roughly speaking, when I have a 94, that means if you're going from the weakest score, Tanzania, up to the best score, Japan, with France, you go 94% of the way. So you're much closer to the top than the bottom. Mexico, we are a very populous country in Latin America here, did well, 72 and 67. Brazil, you see, ladies and gentlemen, is around the middle. 64 in terms of overall effect on lifespan, meaning you did closer to the top than the bottom, but the normalized score, it was only 51, and that reflects the problematic performance on the dimension of homicide. Other countries, though, here are some countries that didn't do as well as Brazil. One of them would be India, 25 and 31 on the 100-point scale. The Philippines, 24-47. In other words, we see in general Brazil is doing better than the countries in Asia, we're saying. Now, as far as African countries, Tanzania got 0. It had the lowest score on the overall loss. It was at, I think, was it 15 or 16? It wasn't at the very bottom on the normalized loss. Nigeria, 2%. In other words, it was the second weakest in terms of overall loss. But if you normalize it, it did a little bit better, made it up to 30. But basically, you see the general pattern right here, that there are differences, that they are big because we're talking, remember, about a quarter of a century from top to bottom. And Brazil is a little bit above the middle. And I hope, of course, in days to come, in years to come, Brazil will make its way up. These are not curved grades, by the way. They're based on where the country fell on the spectrum from the lowest to the highest. So if lots of countries were just below the highest, you could have a lot of scores in the 90s. It wasn't, that it was like percentiles where you could only have 10% above 90. But these are the kinds of scores that came up. Now, one last issue, ladies and gentlemen, I appreciate your patience. What about per capita income and its relationship to the mortality scores that we talked about? By the way, before I say that, do you know, of the two scores I showed you, the correlation coefficient between the normalized scores and the raw scores was 0.965, meaning, as I had expected, because of the strong correlations, whether you just take the simple sum or whether you take an equally weighted sum, it doesn't really matter in terms of relative performance. So this is what I would have expected, and this is what came up. But as far as this last issue, look, there's a clear monotonic relationship between GDP per capita and the determinants of longevity. Look, citizens tend statistically to be safer in the wealthier countries. And let me give you a chart that summarizes the relationship. I broke the 26 countries into 4 quadrants. 6 in the top, then 7 in the second quadrant, 7 in the third, 6 in the fourth, because we didn't have a sum that was a multiple of 4. And I simply took something rather simple, the average GDP per capita in each quadrant, and also the average scores on our different measures of mortality risk. And we see that in the highest quadrant, the top 6, the mean GDP per capita, by the way, this is a purchasing power equivalent. In other words, it takes into account not only the income in the local currency, but how much it would buy. So this is numbers from the U.S. Central Intelligence Agency. I don't know what secretive means they used to find out these things. But in any case, 46,700. Notice the scores 90 and 91. These countries did very well on the mortality risk measures. The second quadrant, well, here the mean income was only about half as high, 23,900. Still relatively good scores, 75, 73. The second lowest quadrant, I mean, now we're below the halfway mark. Notice the scores were 41 and 43 in terms of the mortality risk measures. And for the lowest quadrant, where the mean income was only $4,500 in purchasing power, there we had 22 and 36. Now, we know, as you've studied in statistics, correlation is not causation. I'm not saying that because these countries are wealthier, that is why they are healthier. But on the other hand, you can at least imagine an explanation that the more resources the country has to devote to things about safety, the more safety you will get in various ways. Or this, at least it's consistent with that interpretation, if it doesn't perfectly support it, because no correlation is the same as causation. Two last things, ladies and gentlemen. First of all, you might say, Barnett, these results are obvious. You might say, of course, if you're high on one, we'd expect you to be high on the other across the board. Why did you waste so much of our time? We're busy people, and we have our studies, we have exams and whatnot, and you took us away for that to tell us this? Well, I'll tell you, part of the reaction I have is you have to remember that unsurprising is not a synonym for obvious. In other words, I think we should do empirical studies to make sure that even if we have a conjecture, is it supported by empirical evidence? So I don't think it was a waste of time to do this. Furthermore, even if the general directions, the correlations we could probably guess, in terms of the magnitudes of the effects, how many years of life are we talking about, that I don't think you could get intuitively, right? If I had asked you earlier today at the beginning of the lecture how big is the difference in lifespan here or there, I bet most of you wouldn't have known. So I think especially now that we have a way of calculating that's fair across nations, because it avoids camouflage, it does give us new empirical information. Are there any policy implications of these results? And here I would simply say, maybe. First of all, I would think, and I believe given that you're studying engineering and fields like that you believe the same way, it's good to have numbers to quantify. If we can't really deal with problems unless we know how big they are, right? And to the extent that we now know that the country that has best practices, namely Japan, has done so much better than others, it means there's room for improvement. We're not talking about countries doing things that have never been achieved before. We're talking about getting closer to things that already are being achieved. So these numbers do say something related to policy, you might say. Secondly, though, there are new mortality threats on the horizon. One of them, of course, is nuclear proliferation. Another is contagious diseases like Ebola. Another might be the consequences of global warming, in terms of the climate change and the pollution, all the things that might result from that. You might say, well, maybe a country that's done so well on all these dimensions of safety might be particularly able to help us to deal with the new problems about mortality that are coming up. And, I don't know whether that's true or not. I mean, I have the greatest respect for Japan, but if someone were to say, well, because Japan's done so well, Japan knows better than everyone else how to handle Ebola, I don't know whether that's true. Maybe it is, maybe it isn't. Anyway, ladies and gentlemen, I'm finished with what I would say. As I said, I was just trying to present some empirical evidence on the question of cross-national mortality risk, and there are differences, as we see. And I tried to do it in a way that's consistent with what you would want, namely a careful empirical study, trying to think about the pitfalls, trying to get around them, and trying to present the results in a simple way. Anyway, I'm grateful, of course, for your attention, and I'm happy if time allows to answer questions or whatever, Professor, you think I should do. Thank you, ladies and gentlemen.
you very much for the excellent lecture. We have time for some questions. Please say your name and your institution.
Sir, it's fine for me if you... I hear you.
We are recording. Just a minute.
Hello, Professor. Thank you very much. My name is Thomas Hogue, and I work for Gradus Consultoria, a Brazilian management consulting company. My question is, does the database that you use, or maybe some other database, permit analyzing dispersions within countries? So in the case of the United States, maybe the Appalachian region versus California.
Well, you make a very good point that while some things are handled at the national level, there are regional differences. The global burden of disease study does allow for some regional differences. In the United States, for example, it has results on a state-by-state basis. And I believe Brazil is one of the few countries where it does divide the country into regions. I haven't done it yet, but that certainly doesn't mean it wouldn't be something worthwhile to do. And I think I understand your point. In the United States and perhaps in Brazil also, the differences within regions might be comparable to the differences across nations. But I haven't done it yet. But this is a wonderful data source, and of course it's just as accessible to you as it is to me. So if you could do it later today and let me know. No, but I think you raised a very good point, and I have not addressed it here. It was sort of talking about national averages, and it's true. An average, you remember there's variation around an average, and sometimes there's as much information in the variation as in the average itself. Okay, so thank you for your question.
Thank
yes,
you,
sir?
Mr. Barnett. Congratulations for your presentation. My name is Marcelo, and I make my PhD here in mechatronics.
Excellent. Could you bring the microphone closer?
Okay.
Thank you.
My question is, do you have these historical statistics also, or just to, I think that's 2016. 2016.
The answer is I only use 2016 because it is the most recent figure. The global burden of disease study does go back. I could have gotten 2010, 2000. I think it can go back about 30 years. Now, I think the caliber of the data collection may have improved over time. But you are right. That's another dimension. You see, one can look at, I was looking at averages for 26 countries in 2016. And directions for further work would include looking at other years and seeing whether the differences, however large, have been shrinking, or also whether or not within regions of a given country there are big differences. So these are useful ways of doing it. One thing I can tell you is I work in aviation safety, and one of the things I've noticed over time, and that's only for aviation safety, is that the differences between the safest countries and the less safe have not diminished. In terms of risk multiplier, everyone is getting safer, but on the same slope downward. So you're not really seeing that the countries that have more room for improvement are improving at a faster rate. I wouldn't be shocked if we saw the same thing in the data over time, but I haven't investigated that. It's a good question.
Okay, thank
you. In this study, you show many numbers about mortality. I would like to know if we have any studies here.
I'm sorry, I didn't hear you.
Sorry, I'm Angela Canelas. I'm a student in PESI Poly. I would like to know if we have any studies of prevention and about the growing population of elder people.
Okay. I think the answer to the question is no. This was meant to be a descriptive study. This is the situation now. This is sort of like taking the temperature. As far as things that could lower the temperature, obviously that's very important, but that was not the object of this analysis. As far as elderly people, the study does take into account the fact that risks do go up as you get into the older ages for the various sick sources. That, for example, even accidents in transport, the same accident with cars that might injure a young person might be enough to kill an older one. But in the study, the risk statistics for elderly people are included, and they're included in the same way across countries. You know, in Tanzania, not that many people make it to age 75, but the statistics I calculated took into account the risk for those in Tanzania who did make it to 75. But so, in other words, there was definitely a contribution to the analysis based on senior citizens. It didn't specifically take into account the point you mentioned, namely that senior citizens are getting more numerous. And more of us, and I'm in that range too, are basically in the age ranges where risks are higher. You know, I'm in the United States, the so-called baby boomers, people who were born after World War II. You know, there was a big surge in births after the war and after the Great Depression of the 1930s was over. And I was reading an article recently. It said, funeral directors are welcoming the arrival of the baby boomers. So I am in that age range. But the study considered the elderly, but not specifically the elderly. Not more the elderly than other age ranges.
Hi, my name is Flora. I study economics here at USP. And I'm interested at, have you observed any correlations, not at the general income level of the country, but at the income invested in specific policies regarding the ETNCU?
I think the simple answer is no. This is certainly something one can do. You know, the objectives of this study were modest. Say, here, let's get a sense of the general patterns. And then, of course, you're talking about more specific, more fine-tuned analysis. I was sort of, I'm not an economist, I was sort of macro, and you're thinking about micro, which is very important. So I agree. That's something one can do.
Hi, my name is Antonio, so I'm a professor here at Polytechnic School. Hi. And two questions, in fact. One, in health, you know, you have the term comorbidity, so that one factor may impact the other one, and so on. Did you have any access to some data about comorbidity? And the second one is, in the case of Brazil, you have two different sets for the correlation. You said, oh, it's a special case. Do you think this can have something with camouflaged social apartheid?
I think the answer to the second question is I don't know. In the whether the calculations try to avoid camouflage because they looked at mortality from each source, but I don't know whether or not. I mean, there would inevitably be some interaction in the sense that if you have, for example, homicides tragically tend to kill young people. And so you, in a country like Brazil where tragically your homicide rate is high, then you get more people who don't make it into the later age ranges because of the homicide. The average Brazilian loses over a year of life through homicide, which really means maybe 1 in 60 Brazilians loses maybe 30, 40 years, or maybe 50 years actually, for 55. So I don't know. As far as your first question, the comorbidity, well, I'm sorry, I'm getting the questions mixed up. Could you repeat them?
Yeah, I mean, sometimes you have, let's say, for example, that you have an accident and somebody dies, but in fact he had the accident because he had a heart attack that was not diagnosed, for instance. But you can have this kind of situation in various degrees.
Well, the answer is no. I can't. The study I looked at, the Global Burden of Disease study, identifies the cause of death. Now, you make the valid point that really there may be several causes of death, and we're putting something in one category when it really perhaps should be in several. I couldn't possibly deal with that. It's a sensible issue, but I couldn't possibly deal with it with the data set I used. Most of the people asking questions are around here.
Yes. The older ones, the ones that are... So, good morning. Thanks for the talk. My name is Jaime Sichman, and I'm also a faculty member here. I was wondering if you could give some more technical flavors. Which was the amount of data that you have used, and if the distribution was normal or not normal, which kind of the technicality. Could you resume a bit for us to be aware of the techniques you used?
Well, I didn't really use very much data. I used the data, the rates of mortality in various age ranges for the Global Burden of Disease study. For, most of these calculations, actually, don't forget, they tell us the risk of dying in a certain age range of a particular cause, and they also tell us how many years of life you lose on average if given death in that range. So that was basically, frankly, my only major data source, except for the study about GDP per capita, which is not in the Global Burden of Disease study. That I got from the U.S. Central Intelligence Agency, which supposedly did careful calculations that fairly compare incomes in different countries. As far as distributions, I didn't really work with the distributions here in the sense that, don't forget, for a given country, and these are big countries, the level of statistical sampling error in the results is probably small. Because if I'm estimating a rate based on, 80 million people, then it's true you'll have random variations year to year, sort of Poisson or something, but I wouldn't expect that to be a major problem. I think these data sources are not perfect, and we can't easily quantify the extent to which they're not. To be honest, though, they do sometimes give you a little bit of a sense of the range around a particular value. I took the midpoint, actually, because, again, this is meant to be sort of a general study. And if we started considering, some of these secondary considerations, which, as you say, are important statistically, and we really wanted to work things out probabilistically, I thought in terms of the general message, and I may have been wrong, but I thought that the effort would exceed the return. The cost would exceed the benefit. But I would be the first to join you in saying, as the questions indicate, this is only one, a starting looking at the patterns. And there are many ways, as people have pointed out, that one could look at them in greater detail. And I hope that people will, and maybe I will. But anyway, ladies and gentlemen, are we more questions? I'm happy to take more. There may be one or two people over here who haven't asked a question yet. But
more questions? No? Just a moment.
I'm Gustavo Pierini. Taking one of the questions here, I mean, you did a cross-section, not a serious analysis. So the first question is, if we do a serious analysis, time series analysis of this, maybe, and we know which actions each country took, we will know the effectiveness on the indicators of each action, correct?
I think, well, first of all, I understand your point, a time series rather than a cross-section at a given year. To be honest, given what people have said, this is one of the first things I may try to do soon. But I haven't done it yet.
But the possibility is to understand the effectiveness that will take on the indicators of different policies. And second is someone willing to do something at the level of worldwide, like United Nations, to take action on this? Say, Japan is the benchmark. Let's follow him.
I don't know. I think the first thing, I would do as an academic is try to write up a paper to get it accepted in a peer-reviewed journal where people would check the methodology, and then to the extent that the findings might be of interest, to try to find ways of disseminating those findings. You know, not everyone in the world reads the academic journals. Even the academics who open them up don't really read them in many instances. So I think, though, that you're right. One could write to people who are worried about international health and safety and say, here are some statistics. So I think that's a good idea.
Okay. I think we are closing here. I think we are done, right? Unless there is any question in the audience. Any further question? Otherwise, I will say thank you, Professor, for being here. We are more than glad. It was very illustrative of what can be done with knowledge. And I guess that the next step is disseminating this, and probably the politicians will take action. But this is the initial point. Okay.
Anyway, ladies and gentlemen, thank you so much for coming. I really have enjoyed my stay. Thank you.
It's a little bit heavy, but if you have time to read,